A very important steps in forecasting is monitoring the forecast. So it's just not enough to build a very good model, forecasting model, and then make a forecast and then forget about it. It is very important to always monitor the forecast, the results of the forecast and the performance of the forecast so you can actually improve your model or adapt your model. If there is a change, it is most of the time there is change in the data and the system. So tracking forecast errors and analyzing them can provide useful insight into whether forecast is performing satisfactorily or not. If there is always errors associated with forecasting, as we mentioned early on, that all the prediction models have error. They are not perfect. So the sources of these forecast errors can be due to a lot of factors, including there could be some important factors that you haven't included in your model. This is one of the very common um, sources of error here. The omission or not inclusion of an important variable, which reflects a factor in your model. Or there could be some changes or shift in the variable in the model that the model cannot handle. So you have considered the factor or the variable in your model, but there is a shift in that variable or factor in reality, in the real system, that your model cannot handle. Or there could be that a new variable, a new factor has turned into effect in the real system that it's not in your model. For example, a new technology may have surged in the market, or any other factor that might have been the case. So that variable is not in your model. That could be the um, result of the sources for the error of your model. Another type of sources for error in forecasting technique is irregular variation. So, for example, any types of irregular variation, such as a labor strike or a weather event, a hurricane, a flood. So when those situations, those irregular variations happen, so that's going to impact, that's like another factor that is not in your model, is not a variable in your model. So that could not make the prediction very well. So that's very obvious that your model is not going to give you a very accurate prediction, far from it. And a very common and unavoidable part of any prediction is for the source of error for any prediction is the random variation that you have to just accept. You have to just accept it that there is random variation in every system. There are sources of error that we cannot assign to any other types of factors. Is in just the nature of any system that is going to change due to this random variation. What if you had seasonality in your data? The technique that we have talked so far are not appropriate if you have seasonality in your data. So seasonality, as you remember, you can actually detect them by as simple as plotting your data and observe the pattern of seasonality in your data. Seasonality is regular repetition of variations in your data that can be due to any recurring events. The seasonality is expressed in terms of the amount that the actual values deviate from the average value of a time series. There are two ways to handle seasonality in a predictive model or a forecast model. One way is in what is called as additive approach. In this approach, the seasonality is expressed as a quantity that is either added or subtracted from the average of your time series data to incorporate the seasonality. The other approach is as a multiplicative parameter. So seasonality is expressed as a percent of the average amount that the value of time series changes. This is how you could also incorporate seasonality into your uh, data and in forecasting model. How to select a forecasting method? So this depends on some analysis to do, peer analysis to do. For example, whether your data has trends, seasonality cycles, any other type of patterns. This is important for give you insight of what type of forecasting method and techniques you should use. For data that do not have any trends or seasonality, any pattern, you could use the simple naive forecasting method, or you could use the moving average, the averaging method, the moving average, the simple moving average, and the weighted moving average method, or the exponential smoothing method. In these methods, however, you need to also pick either the weight or the time window. That means that the time periods that you want to average over n. And also in the exponential smoothing, you need to select a value for alpha, the smoothing constant. Then the question comes to this point that if you choose different techniques, you're going to get different answers. But which technique should you pick? How would you pick a technique without knowing the performance in the future? How could you pick up the model or the technique that is most likely to be close to what will happen in the reality? Meaning that which model should you pick so that its prediction and forecast is more accurate? Well, there is not really a clear answer to that. What we can say is we can calculate the past performance of the technique. So we can compute the forecast accuracy technique that we have based on the historical data. And this is like an educated guess. And then we can hope that the almost the same level of accuracy or close to it, something close to it, it can occur in the future as well. Does this always is this always true? Not necessarily, but this is the best that we can do to encounter uncertainty, the future uncertainty.